keep taking you through the life cycle of a program with one consumer, one producer, one event. So what's going to happen is I'm going to create a topic inside the script as shown. Now I create a topic greatest of all time under the type sports with no partitions yet. I'm going to create a partition ESPN under the ID greatest of all time list. That creates a partition here, ESPN. Now I'm going to create an event. Now the event's going to take in the string as a value. I'll show you later that you can actually take an integer as well because we implemented generic type. So we're going to also create a producer CMA Smith under sports. So run it. Yeah, cool. I produce the producer CMA Smith with allocation type random. Produce also an event on the ESPN with run James pretty good with just a string. I'll show you right now that I can also implement. I can change this to an integer. It'll still work. Run event. Yep, value 1 doesn't matter. Okay, so I'll change it back. Now also create a consumer group and a consumer. So consumer group has range and consumer is American, which is consumer group, and also has the ID, the Smith family. So I create it and we can see it's created. Right here, consumer group, Smith family, subscribe to ESPN. Cool, and then we will consume event. So Smith family will consume from ESPN. Bam. And then you can see Smith family, the event shows up in the log, the project is pretty good.
So secondly, we've implemented parallel produce and parallel consume. As you can see here, we've created 3 different producers. We've got 3 events, and we're going to be producing into one partition. The way we implemented this was through the singleton pattern by making the constructor private and a public method to actually get the tributary. We then synchronize the methods that access the shared resources, which in this case are the partitions that are being added to and consumed from. So first we'll call parallel produce, which should produce 3 different events in the partition design. As you can see here, there's no race condition, it's all 3 events as we want. So we've also created 3 consumers to do our testing with from 3 separate groups. So first we'll call consume once on the partition, and it takes the first event that was created because it's a first in first out system, and the Smith family consumed that event and it's no longer in the list. And then we'll call consume again. It should take out the second one that was inserted, and as you can see, the Smith family got it again. Now we're going to call parallel consume. So pretty much it takes in a list of consumers and a list of partitions that we want to consume from. And what should happen is it should take out the last event, and the last 2 consumers won't get anything. There'll be no race conditions because it's all synchronized. And as you can see, the Adams family got the last event, and the Chan family unfortunately got nothing.
As far as I can check, we also have to show that events can be created under different topics with different payload types. So we create 3 topics: greatest of all time on sports, the big debate over type news, and also comp 2511 and units. So we also created 3 producers: Stephen A. Smith, Stephen Simpson, and also Alvin Shirk. Yeah. We also created 3 objects, 1 for each payload type. So we've got JSON1 for sports, JSON2 for news, and also JSON3 for UNSW right here. Now I'm going to try produce event from say Stephen A. Smith. And produce event, as the spec says, will take in a producer ID, a topic type, and JSON file or event, and it'll produce event. And it should produce under ESPN as expected. Now let's produce the next one, which should be by Stephen Stevenson under news. And I'll run that. And it should show, yep, no news, create a new event, create a news, the value is I think we should pay colors. So next part of code, we need to show that the random allocation method works. So I'm going to show you that first. So right now I've created one topic with 3 different partitions, and also created 1 producer, Stephen A. Smith on the sports, with the allocation type random as stated here. And I've created 3 partitions, ESPN, KO, and sports bet. So what I'm going to be doing is I'm just going to be running produce event continuously a couple times, and you should see that the event should end up in ESPN, KO, and sports bet in random order. So it should change every time I run. So I'll produce event now, and the first time it will be created under KO, right? So the event's created KO here. LeBron James pretty good. I run again. This time it's under ESPN. So let's produce again one last time just to show it works. ESPN again. Randomness is implemented through pseudo randomness. We have a rand function in the strategy pattern that we discussed in the report. Right. Now we also have a manual strategy, so we'll show the manual strategy now. So this time I created Stephen A. Smith under the allocation type manual instead of random, and when I produce the event, I said to partition ID ESPN. So I'm using the produce event with extra argument partition ID, and that what's going to do is it's going to select ESPN every single time instead of being random. So this time you can see ESPN. I run again, ESPN, and when I change it to here, I want it to go to KO because I like that subscription service better. It will go to KO as shown. Now for the third checkpoint, we're also going to show how consumer group works. So what I created here is like example before. I created a bunch of events, a bunch of partitions, ESPN, KO, sports bet, add a couple more just to show the different rebalancing strategies. Under the greatest of all time topics. So there's 1 topic, 5 partition, and we'll show rebalancing strategy right now. So I created the first consumer group. It's called European under the topic greatest of all time, and it will have a rebalancing strategy range. Right, so and then I'll add 3 consumers to this consumer group: the Adams family, the Gobbledygook family, and the Dracula family. So I run it. And we can see that there's 3 consumers that's added to consumer group European: Adams family, Gobbledygook family, the Dracula family. And I've also printed now what a subscription is subscribed to. Adams family take the first 2, Gobbledygook family take the next 2, and Dracula family take the next one. Now, alright. Next one we'll show is the rebalancing strategy for round robin. Now, same set as before, but now instead of range for round robin, and we can see that the European group has a different allocation of partitions. So Adams family will have ESPN, then Gobbledygook family take KO, Dracula family take the next one, which is sports bet, Adams takes FIBA, Gobbledygook takes NBA Live. We're going to talk about rebalancing when we delete it. So we can delete consumers, for example. If you see here, we had everything just as before. Now we run delete consumer, the Adams family. Adams family doesn't want to be subscribed anymore, so we delete it. Bam. And look at the European family. Yep. It only has the Gobbledygook family and the Dracula family now. And rebalancing changed as well. Now the Gobbledygook takes ESPN, Dracula takes KO, Gobbledygook takes sports bet, Dracula takes FIBA, Gobbledygook takes NBA Live. So it rebalances as well once we delete it.